Hello GCC, this is our last video for Chem 107 Chapter 6. It'll be a little longer than the others, so bear with me, but let's wrap up this chapter. So Southern California has had in the past some problems with acid rain. It's like it's not enough they're having all these forest fires, they also have acid rain trouble. Back in January 1982, they had a fog right above LA in the Pasadena area that had a pH of 2.5. That's pretty acidic. Later that same year in 1982, Corona del Mar had a fog that was pH 1.5. That's actually strongly acidic. But their SO2 concentration was pretty low. So some things besides SO2 and SO3, SOx, must contribute to acid rain. Does it have to do with all the traffic in the LA area? Well, there's not a lot of sulfur in gasoline, but there is nitrogen and air that gets sucked into the gasoline engine. And in a gasoline engine, nitrogen and oxygen at high temperatures can make NO. Coal plants also emit a lot of NO. So 35% of nitrogen monoxide, NO, comes from coal plants. 58% comes from transportation and 5% from industry. So the transportation is a problem in Southern California. With all those cars, we got a lot of nitrogen monoxide coming out, makes the rain and the fog, all that sort of stuff, acidic, very acidic. So that's a problem for them. The effects of acid rain. Well, acids can react with some metals. Iron, for example, can react with acids. What do we use iron for? Well, bridges and railroads and cars and trucks and fences and steel rods in construction, ships, buildings all contain iron. Iron will rust faster in the presence of acid. So if we have acid rain and acid fog, all of those things, bridges, railroad ties, vehicles, fences, ships, buildings, they're going to rust faster. So I remember when I moved to Indiana, a lot of the cars had, the side of the cars were rusty and pieces were flaking off. And I thought, wow, being from Texas, I had never seen this before. That's one of the impacts of acid rain. We actually spend billions of dollars a year to protect exposed iron by painting it and coating it. So we have to spend a lot of money on this. Marble and stone also dissolve slowly in acid, so it's ruining gravestones, works of art, historical landmarks, statues are all being lost slowly as they dissolve in this acid. There's also haze, visibility problems. So when you're driving, you might see haze in front of you. Haze is caused by little droplets or particles suspended in the air. Sulfuric acid can make little droplets in the air which scatter the sunlight and cause haze. Breathing these little droplets causes lung damage and drives up healthcare costs. If we could reduce SOx and NOx, we would save billions of dollars in healthcare costs. So a lot of people are upset. The coal power plants pollute, but individuals pay their own healthcare costs. Is that really fair? Something to think about. So here's just a picture showing haze from little sulfuric acid droplets on a typical day. It's hard to see through all the haze. Acid rain also causes damage to lakes and streams. So humans are not the only species that are having trouble due to acid rain. A healthy lake has a pH of about 6.5. Below 6 damage can occur. The lake is pretty much dead by pH of 5, and it is completely dead by a pH of 4. So as we have that acid rain in the lake, it's slowly dying. Now luckily, a lot of Midwestern lakes contain limestone, which is a base, and it neutralizes that acid. But New England, the Northeast, is not so lucky. Their lakes are becoming more acidic, and they're dying. It also kills forests. So here's a picture where there was not a forest fire, but acid rain contributed to the death of these trees. So it impairs the growth of trees. It increases the chances of insect infestations. It increases their chances susceptibility to drought. Acid rain will also leach and deplete the forest soil of crucial nutrients. So acid rain damages forests. Here's a great EPA website you might want to look at if you're doing your acid rain paper. epa.gov/acid rain/effects-acid-rain. So ocean acidification. I mentioned earlier, people call it climate change's little sister. So climate change is the world heating up because of CO2. Ocean acidification is the ocean becoming more acidic due to the CO2. So fact, CO2 levels are higher than any time in the past 800,000 years. Fact, CO2 levels are increasing at a faster rate than any time in the past 800,000 years. So I know we've talked about how things kind of change naturally at a slow pace, but right now things are increasing at such a fast pace that it's off the scale. We've never seen anything like it. Another fact, large areas of coral have been discovered to be bleached out, meaning they're dead. Another fact, the ocean is about 30% more acidic than it was before the Industrial Revolution. Wow, that's substantial. Here's a picture of healthy coral. Here's a picture of bleached coral. So we can see healthy coral supports lots of fishes and animals, and that's where tourists come because they like to snorkel and scuba dive. Bleached coral, everything is dead. Tourism is gone. The hotels, the restaurants that supported the tourists, gone. So it can collapse an entire city, and a little ecosystem dying can really have a grave effect on humanity. So there's a bleached coral reef. No more tourists going there. There's nothing to see. In this graph, in this map, we see blue and yellow where coral can grow. This is 1880. We have a lot of coral reefs. A lot of coral reefs in the blue area, some in the yellow. Orange and red is where coral cannot grow well. This is 2000. Look at what we've done. We've decreased the blue areas significantly. Look at those coral reefs where they are now. And if we do nothing, this is 2050. The blue and the yellow are gone. In other words, the coral reefs by 2050, and this is your lifetime, could all be dead. What is happening to our oceans? Well, again, water can absorb CO2 gas. Guess what? It's the equation I've mentioned over and over again. CO2 plus H2O water makes H2CO3, carbonic acid. So carbonic acid is being absorbed, CO2 is being absorbed into our oceans, making carbonic acid, which increases the acidity of our oceans, so the pH is going down. The ocean pH level has decreased more than 0.1 since the 1800s. That's about a 30% increase in H+ ions in seawater. It's predicted by 2050 the pH level will be 0.23 lower, and by 2100 it'll be 0.36 lower if nothing is done. The pH of the ocean is still a little basic. It was at 8.2. Now it's 8.1. It's moving to 8.0. But it's becoming more acidic. The pH is going down as we put more CO2 into the air. This is just a little picture showing CO2 in the air comes down, gets dissolved in the water. So CO2 plus water, again, here's that reaction, makes H2CO3 carbonic acid. Carbonic acid can release H+ ions, hydrogen ions in the water. What happens is we get deformed shells, little shelled animals. Their shells are deformed when we put so much CO2 into the ocean water, making the carbonic acid. The acid reacts with the shells. So why do we care if the ocean becomes more acidic? Well, as I mentioned, all the shelled animals care. Their shells are made of calcium carbonate. In a basic solution, calcium carbonate will not dissolve, but as the water gets more acidic, the shells start to dissolve and deform. So corals, echinoderms, crustaceans, pteropods, and mollusks all care because it's getting harder to form their shells and it requires more of their body energy. Also, the animals that live off the coral will be threatened because their ecosystem will die. This will disrupt the entire food chain right up to humans. Here's just a picture of pteropods in case you didn't know what they were. They're also called sea butterflies and they're very small. So pteropods actually do have some shells and it's harder to make their shells now that the ocean is becoming more acidic. Here's the echinoderms. So your starfish, sand dollar, sea cucumber, and sea urchins are all echinoderms. They're having a harder time with their shells as the ocean is becoming more acidic. Crustaceans, that's your lobsters, shrimps, and crabs. They're having a harder time maintaining their shells. And finally, mollusks. That's clams, nautilus, and snails. Those are mollusks. They have shells. They're having a harder time maintaining their shells. So consequences. The animals that live off the coral are threatened. This will result in disruption to the entire food chain. Scientists predict that within 30 years, shells will begin to dissolve, including the coral reefs. The Great Barrier Reef of Australia is already slowing down and having some dead areas. Coral reefs protect coastlines from rough waters and provide homes for many species. So we want to have these coral reefs. They help us during hurricanes. This is going to affect humans involved in tourism and the fishing industry. No one's going to want to go scuba or snorkel at a dead coral reef. Several fishermen are already complaining of decreased fish in the ocean due to many reasons, but climate change and ocean acidification play a major role. And that wraps up Chapter 6. Thank you so much, Kim 107. Have a good time reading your chapter, listening to all these videos again. Get ready for your Chapter 6 quiz. Thank you.